All right, so we're going to move on to lesson two. In lesson one, we talked about the standardizing the normal curve. We talked about how you can find the z-score given any x value, and how any graph, regardless of where the standard deviation is or where the mean is, if it's normally distributed, can be standardized into a normal standardized curve with a mean of 0 and a standard deviation of 1. So now we're going to be moving into 6.2, which is where we're going to be focusing on the area underneath the standard normal curve. So the reason we would normalize a curve and standardize it is so that we can find the area underneath the curve. And so let's just go through some of the basic properties of a normal curve first. The first property is that the total area under the curve is 1. That's all the probabilities. So that's 100% of the people in a survey, or 100% of the observations are within the normal curve. That's the first property. The second property is that the normal curve extends indefinitely in both directions, forever to the left and forever to the right. However, we know from a previous lesson that about 99.7% of all the data in a normal curve is within 3 standard deviations of the mean. So even though it does extend forever, boy, it's very seldom that you would see a standard deviation of -4 or +4 or higher than that. The third property is that the standard normal curve is symmetrical. So the middle is at 0, and then the right side and the left side of a normal curve could be folded on top of each other, and they have the same shape. And then the fourth property is something we've just talked about, and that is that almost all of the data in a normal curve lie between -3 and 3. And so we used to find the area of normal curves before graphing calculators with tables. And so if I wanted to find the area of a normal curve to the left of 1.23, I'd have to come up with a table like this. This would be 1.23, and that would be 8.8907. In other words, 89.07% of the population would have a z-score of less than 1.23. Well, we can do that a little bit different now with our graphing calculators. And so I'm going to pull up my graphing calculator here, and I'd like for you to use your graphing calculators. Hopefully you have one that you can use when you're at home. But I'm going to do this. I'm going to turn it on first, and I'm going to go to second vars, and I'm going to go down to normal CDF. So if you go down to normal CDF and press enter. Now, this is a TI-83, and it's different than a TI-84. The TI-84 will actually give you a menu, and I just can't display that on my screen. So I'm going to kind of explain what that menu is on a TI-84. There's a lower value and an upper value. And for the TI-84, you would type in a lower value. We could use anything to the left of a normal curve that would be like -infinity. But instead of using -infinity, we know that most of the points are going to be between -3 and +3. So I'm going to go a little bit past -3. I'm actually going to go all the way to -10. So you can type that in just like I did on a TI-83 first, -10. But if you're using a TI-84 where it says your lower bound, you're going to type -10. Notice it's not -10, it's -10. And then if on a TI-84 you would go to your upper bound. So on a TI-83 we're just going to use a comma. And then our upper bound is going to be 1.23. So we're going to have a z-score of 1.23. And if you're using a TI-84, for the upper value you would just type in 1.23. And then you'd go to paste. And then in a TI-83 I could just close those parentheses here. I'm going to close those parentheses here, and then I'm going to press enter. And if you press enter on a TI-84, you get 0.89065, which would round to 0.8907. That means that on a normal curve between to the left of 1.23, a z-score of 1.23, of the population is going to fall within that range. Let me show you what this would look like if I were to do this on a normal curve. Let me try, see if I can adjust this a little bit. So on a normal curve, we would have something like this, and here is 0 here, and then this would be 1.23. What we just found is this area right here. 89% of the population has a z-score of less than 1.23. And that's what we did with our calculator. Let's practice this. Let's practice this a little bit more with some other examples. We just did number 1 here. Find the area and the standard normal curve to the left of 1.23. If we want to find the area on a standard normal curve to the right of 1.38, well, again, I'm going to pull up my calculator to do this. I'm going to go second, vars, and I'm going to go down to normal CDF and press enter. And again, this is going to be different if you're working on a TI-84. Here, to the right of 1.38, my lower limit is 1.38, and I'm going to put a comma in there. My upper limit, I'm just going to put in positive 10. And I'm going to close those parentheses, and that would mean that to the right of a z-score of 1.38, that's 8.37% of the population. And then if I wanted to find the area on a normal curve between 1.02 and 1.42, again, I'm going to go to second vars. I'm going to go down to normal CDF, and my lower limit is 1.02. So I'm going to have 1.02. I'm going to put a comma in there, and my upper limit is 1.42. And I'm going to close those parentheses, and 7.6% of the population has a z-score between 1.02 and 1.42. Okay, so that's what we're kind of working on here. If I take a look at one more thing that we want to be able to do, we want to do 2 things today. We want to find the area between 2 values, or to the right or to the left of a value in a normal curve. Then we also, if I'm giving you the area, we want to be able to find the z-score. And so that's what this represents, a z sub something, a z sub alpha here is what we're talking about. And if I have, this is what this is going to look like. If I have a z sub 0.025, that means that's the area. The area underneath the curve to the right of some z-score has an area of 0.025, and we want to find the z-score. So this is just the opposite of what we did before. Before they gave us the z-score and we wanted to find the area. Now they're giving the area to the right and we have to find the z-score. And so it's going to look something like this. Again, I'm going to go, let me clear all this. I'm going to go to second and vars. And now I'm going to go down to inverse norm. If you go to inverse norm, it's asking now for the area to the right of a certain z-score. It's always going to be to the right. So the area to the right of a z-score is 0.025. I'm going to close those parentheses, and that is a z-score of 1.96. It must be to the left on your calculator though. No, wait a minute. So that's different. Let me do it on a TI-84 first. TI-84, if you go to inverse norm, I guess the area is always to the left. Yeah, so we would have to convert this 0.025. We would take 1 minus and then 1 minus and then 0.025. I'm going to have to use minus, not negative here. So that gives us 0.975. So I want to find the area over here that is 97.5% to the left of that. Then I would go second vars, I'm going to go down to inverse norm, and I want to know the area to the left of that, which is 0.975. I'm going to close those parentheses, and that gives me 1.959, which is really close to 1.96. So it's kind of weird because in the software that we're using has a z-score, and it always gives you the area to the right. We're going to have to convert the area to the right to the area to the left by subtracting 1 minus that number, and then we can find the z-score from there. So for example, let's say we want to do the same thing down here on the second example. The area is 0.05 to the right, so we're going to have to go 1 minus 0.05, which is 0.95. And then to find this z-score here, we would have to go second vars and go down to inverse normal, and we're going to type in 0.95 for our area, and that's going to give us a z-score of 1.645 if we round it up. So there's two things that I'm hoping you're able to do because of this video, and those two things are, if I give you a certain z-score, you should be able to find the area to the left, to the right, or between two numbers. And then the second thing would be, if I give you a certain area to the right or to the left, you should be able to figure out what the z-score is if I give you that area. So hopefully this makes sense, and if not, in class or in our Zoom meeting, we can figure out how to do that a little bit better. But that's assignment number 2, and we have a Math Excel homework assignment on this, and hopefully that works out well, and if not, we can go over questions on it next time. Good luck, everybody.